Meantime, getting $50 million from the U.S. Army to design new uniforms for soldiers out of nanotubes. The next generation soldier just might wear tiny tubes filled with ferrofluids, which harden it into armor when they're activated by a magnetic field. Another idea, use the nanotubes to reflect light, creating instant camouflage, almost approaching invisibility. And still another approach would improve the uniform by giving troops a super powerful outer shell. Bob Hirschfeld shows us how soon the idea could come to market.
Do you remember this scene in the second Alien movie?
Get away from her, you bitch!
It was 15 years ago that Sigourney Weaver fought her nemesis. The creature could easily have overcome a mere mortal, but Lieutenant Ellen Ripley was wearing what is now called an exoskeleton, a robotic-type device, but one that can be strapped on or attached directly to the human body. It adds lots of muscle power for heavy lifting and long-range running and walking, and as in this movie scene, even fighting. Machines that assist humans have been under development for a dozen years or so. This early model was built at the University of California at Berkeley. It follows the lead of the operator's hands and can lift heavy objects using hydraulic motors, for example. Now, the military is getting involved. The Defense Advanced Research Projects Agency, known as DARPA, is spending $50 million over the next 5 years to give infantry soldiers an extra edge when they carry heavy backpacks, ammunition, and weapons. An exoskeleton can take over the load.
When the soldier walks, the person will feel maybe about 5% of the entire load of the backpack, and the machine takes 95%.
It's all a lot more complicated than it might seem at first glance. For example, this device includes prototype sensors that deal with the interaction between the exoskeleton and the human who's attached to it. The machine must react appropriately with the right amount of force or movement that the human needs at any particular moment. Too much pressure and it could injure you. Not enough would be ineffective. The students here have also developed this device they call the Pogomatic. It looks like a toy, but in fact it's helping them develop a tool that could help a soldier move at top speed.
So essentially, if this were to one day turn into a running exoskeleton, you could envision essentially having a smaller pogo stick strapped onto each leg. And then if you could imagine, if I were to have my foot here and one of these connected to the hip on each leg, I could then take long strides bounding along and running with a fairly heavy load on my back.
The exoskeleton project requires researchers to develop not only the propulsion devices but also a miniaturized power system. The Berkeley lab developed this exoskeleton prototype about 5 years ago, powered by a simple lawnmower engine. That obviously isn't quiet enough for the military, so researchers are looking at other types of motors, including fuel cells. They also need to deal with the issues of comfort and fit.
All you see here is interface between the human, machine, and the ground. It had to be comfortable, it had to accommodate different people, moreover it has to have good sensory systems.
The government's timetable calls for researchers to have a lower body exoskeleton ready for trials next year and a whole body version by 2005. Bob Hirschfeld, TechTV.
Now, we should tell you the exoskeleton isn't a new idea. In fact, one of the examples you saw in Bob's report has been tested in factories as a way to move heavy objects off assembly lines. Future systems could help people who may have lost a limb or give extra stamina to those with weak muscles.